So we will start our class. Okay. First, you have to open the INU Smart Campus apps to check the attendance. So now you have to enter 0923. 0923. Okay. 근정봉. And also you have to.
네,
왜 너 왜 출석 체크 안 해?
지금 하고 있습니다.
Okay. Open the all of the cam. Okay. I cannot see you. 권정봉, 송영기, 서지. I cannot see you very well. 서지. Okay, so you have to enter 0923 to check your attendance. Okay. Okay. So now we will start our class. Already a lot of students is not here. 양예연, 조영훈, 안나연. So you have to enter 0923 to check your attendance. So
I'll do it now.
okay, so you have to open the INU Smart Campus apps to check your attendance. Now you have to enter 0923. Okay. Okay.
Yes.
Okay. Okay, now we will start our class. Okay. And please open your cam. 이강규.
네.
황승민은 이거 뭐야, 이거? 황승민은 뭐야?
네?
너 이거 뭐야? 너 왜 몸만 나와? 오케이. 문경록, 김유나, 김지연, 김준수, 메카트로닉스.
네,
잘 듣고 있어?
네.
엄청 어려울 텐데. 엄청 어렵지?
아직까지 괜찮습니다.
괜찮아? 오케이.
네.
오케이. Okay, so now we will start our class. Okay. Okay, so now we go to the protein engineering course. Okay. So here there is an announcement for midterm exam, 8 weeks. So our midterm exam will be held in October 21st, 1:30 p.m. and unlimited. So I found that all of students can solve the midterm exam within 1 hour. I think you guys also can solve the midterm exam within 1 hour. However, our midterm exam time is unlimited. Just take your time, okay? Okay. And test range is from chapter 1 to chapter 5. Okay. So I already also showed that another important announcement for detailed information of midterm exam. So the midterm exam will cover only from chapter 2, chapter 3, chapter 4, and chapter 5. Okay. So in chapter 1, there is no question. Okay. Okay. Please make sure that in chapter 1 there is no question. Okay, so I found that nearly all students, our test range is from the chapter 1 to chapter 5. Actually, from chapter 2 to chapter 5, full score is 50. And also our homework full score is 40. Okay. So in the actual exam, I found that last year I found that nearly 95 students have a score above 93. I think that if your score is above 93, you will have higher chance to get A+. Okay. Yes, now I will explain some important procedure, test method. Okay. So you have to connect Joon. Important, you have to solve the test questions while showing yourself in the real time through Joon. Okay, this is important. So we already did for example, pre-check task for taking midterm exam. So we have the number 1 and number 2. I think everybody already submitted all of the requirement for take a midterm exam. Okay, so everybody already submitted. Okay. So this is important. Okay, once again, this is very important. So last year I found that one student is not ready to this step. So I did not give him the chance to get midterm exam. Okay, so last year one student was not prepared for this important step. So at that time, I did not give him the chance to take exam. Okay, this is very important. Okay, so at that you can download the midterm exam document file. So you can download this file at 1:30 and October 21st. Okay, so you have to enter the Zoom meeting around the 1:25 or 1:20. Okay, so I have to check. I will check all of them. You are ready or not? You are ready or not? You are ready or not? Okay, at that our exam will start 1:30. Okay, and also print midterm exam file and write down your answer. Or if you don't have a printer at your home, just you can write down the answer in the paper. That's all. It's good. And also there is another important step after you finish midterm exam. So you have to write finished exam in Zoom chatting window. We have Zoom chatting window. Okay, we have Zoom chatting window. So now for practice, you can write down for example, 강지호 finished exam. You can write down right now. Okay, 최병희 finished exam. Okay, 노유미. Okay, it's good. Okay, Tibor finished exam. Okay, like this. Okay, so I will check it. So I will record all of our Zoom. Okay, so I will check it again. So after you finish exam, you have to write finished exam in Zoom chatting window. Also, next thing is important thing is take a picture and your answer sheet by your phone and send it to professor's phone or professor's calculator within 5 minutes. So I will check the time difference between this one and this one. Okay, very important. very, very important. And at that, make answer sheet as a PDF version. You can take a picture and convert it PDF, or scan it and convert it to PDF. At that, you can submit answer sheet through the assignment in the e-learning. So do you have any question? Do you have any question? 다 이해했어요? 한성준, 이해했어?
네.
Okay. Okay, maybe everybody already understand it. Okay. Okay. Question language. Okay, so don't worry. Questions in midterm, midterm exam are given in both Korean and English. And also your answer, you can write down the answer in Korean or the English. Okay. Okay, so don't worry. Don't worry. Okay. And also detailed information of our midterm exam. So you need calculator. Important, you need calculator to solve the problem. So you need a calculator to solve the problem. Okay. And our total score for midterm exam is 90 points. So homework from chapter 2 to chapter 5, 40 points. And our actual midterm exam is 50 points. So the exam is like this. Okay. Total is 50. Okay. Okay. And also everybody already submitted pre-check task for taking midterm exam. Okay, thank you. Okay, and also our homework submission status, and all of students already submitted all of the homework. It means that you guys already had number 40 points. Okay. Okay, so do you have any question? Do you have any question? 한동혁, 이해했어? Okay.
네,
이해했어? Okay. 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 Now, okay. So now we will go to the introduction again. So here, our percentage over the grade evaluation. Attendance is 20%, and midterm exam is 40%, and final term exam is 40%. So midterm exam is composed of homework is 40 points, and midterm exam is 50 points. Total 90 points will be converted to the 40%. Okay. So I found that nearly all of students got A+. Nearly all of students, but some of them got B+. And sometimes some of them one student get the C+ is like this. Okay. Okay. Okay, so what was the important thing during the introduction? What was the important thing I mentioned during the introduction? So during the introduction, I showed that on the YouTube, I said that patient and persistence. Okay, in Korean we call it as the 끝까지 있네. This is very important for your life. Okay, I think I always memorized this one. Think about it. I always think of patient and persistence. Okay, for me, I always do that. Okay. Okay, in chapter 1, we covered, even though there is no question in the actual midterm exam, so we cover chapter 1. Chapter 1 title was the Introduction to Protein Structure and Function. So today we will briefly cover chapter 1, and we will cover chapter 2 and chapter 3. And this Thursday, we will cover chapter 4 and chapter 5, okay? Okay, so protein means that in Greek words, the proteus means that God of sea, and also in Latin, promerius means the important. The protein is important, okay? Okay, and also we cover the several things, and also why study proteins. So now the protein structure and function have impact, very important impact on the medicine. Okay, because the many disease comes from the specific protein defects. For example, sickle cell anemia and something like that. Okay. So there are another example, cancer and something like that. And also nowadays the biopharmaceutics is the most popular thing in nowadays, because I mentioned earlier, biopharmaceutics market is increase, something like that. For example, in 2010, top 10 drug, nearly all of, for example, among the top 10 drug, 7 drug comes from the biopharmaceutics. Okay, now is world is changed. Okay, so that's why we, and also so biopharmaceutics is very important nowadays, and basic concept of biopharmaceutics is this class, protein engineering class. Okay, that's why we learn the protein engineering class right now. Also, there are very important concepts here like this. Okay, so now we finished chapter 1. Okay, now we will go to the chapter 2. So do you have any question in chapter 2, homework or the class? Do you have any question? Do you have any question? So we had the homework or the class. Do you have any question? Because all of homework question was very difficult. Okay, maybe it takes a lot of time to solve the problem. Okay, so we'll cover chapter 2. Okay. Chapter 2 is amino acid, the building blocks of the proteins. And this is we cover, so amino acids include 20 amino acids. So they exist in Zwitterion status. So they have plus charges, and they also have minus charges. So because of these characteristics, they can enable charges interaction. So they can make the crystalline lattice structure like this. It means that they have the higher melting and higher boiling points. So in chapter 1 homework, we cover this one. For example, chapter 1 homework. So why are proteins, why are amino acids are white crystalline solid, and how does the account for their physiochemical properties? So very important thing is they have the higher melting and higher boiling points. Okay. Okay. Also, okay. And also we learned about Henderson-Hasselbalch equation. So this is the Henderson-Hasselbalch equation. Okay. So in these cases, we just, it's equivalent is that sodium hydroxide. So we just add sodium hydroxide. So sodium hydroxide is a base. Okay. So actually, the Henderson-Hasselbalch equation is equilibrium between the weak acid and its conjugated base. So allows the solution to resist the change to pH when small amount of strong acid or strong base are added. So in this for proteins, so when we add small amount of the strong base is added, so usually the protein function as weak acid. So protein function as weak acid, and they show that they show the very plateau status, equilibrium status. So they resist change to pH. Okay. Okay. Once again here, this is a titration curve for protein, especially the alanine. Okay. So equivalent of sodium hydroxide. So we just add sodium hydroxide. Okay. So for example, alanine, they don't have a pKr, they have a pK1 and pK2. So they have two equilibrium status because the alanine function as weak acid. Okay. Another case is that titration curve for histidine. Histidine, this is histidine. They have a pK1, pK2. They also have a pKr. Okay. And also in actual our homework, this is very important. Okay. To solve the midterm exam, this is very important. Okay, so histidine has 3 ionizable functional group. So draw the structure of a maze ionized form of histidine at pH 1, 5, 8, and 13. And also the question is what are respective charges at each page? Okay, this is one example of histidine. Or the actual cation will be the histidine, or for example, another case is that how about another case will be will be the another case can be the lysine. Okay, lysine has pK1 is 2.2 and pK2 is 9.1. Lysine has the pK2 is 9.1 and pKr, this is actually pKr was 10.5. Okay. Or there is also another example can be this one, aspartate. So aspartate, they have carboxyl group. So their pK1 is the 2.0, their pK2 is 9.9, and their pKr is the 3.9. For example, at below the pH 2, okay, so they will be they have the +1 charges. The NH3 is they have the plus around here between the 2 and 4. The total charge is 0. How about page 7? Page 7, their charge will be minus plus, total will be the minus. Above the 10, their charge will be -2. Okay, so this is very important. So okay, so very important to solve the exam. So this one example is histidine or aspartate, or another example is we can see, so for example, lysine, something like that. So you have to know, okay, to solve the midterm exam, okay. And also the important thing in the midterm exam, okay. Okay, so we have the 20 amino acid. So important thing in this class is very important. The important thing is you have to memorize all of the structure. And also you have to memorize the simplest code. For example, glycine is the structure is like this. In our region, they have the H, and glycine is simplest amino acid. And also the simplest code is G. And the other one is, another one is the alanine. In the R group, they have a CH3, methyl group is there. And the simplest code is A. Because this is a protein engineering course, so most basic concept is to memorize all of amino acid structure and also all of the simplest code. Very important, okay? So actual exam, you have to memorize. So to get number 8 points, so there is the question was the 8 amino acids. You have to write down the oral structure, and you have to write down their simplest code. Okay. Okay, because this is protein engineering course, and this is the most basic concept. Okay, so in the company, we always say that we don't call it as alanine, we just call it A. So whenever we say the A, so I always think about the structure. Okay, so for example, A means the alanine, so they will have the CH3 is like this. Okay, so we don't call in company, or we don't call alanine, we just call it A. Okay. How about here? We don't call valine, we just call it V. So whenever we call it as V, so we think about their structure is like this. Okay, and also there is we just call it as the CH in the R group. For example, leucine, they have a methylene group. If they have CH2, we call it as methylene group. They have CH, we call it as methine group. And finally, leucine have the methyl is like this. Okay, so this is a leucine structure. So you have to memorize the structure. And also, we call it as this C as C alpha, and this C we call it as C beta, and this carbon we call it gamma, and delta, epsilon, and zeta is like this. Okay, so in our actual homework, we already solved that. So based on we just write this is methyl or methylene or methine. The methyl group is like this. It's right. Solution is something like that. Okay. Okay. And this is the C alpha, C beta, C gamma, C delta is like this. Okay. Okay. And this is finally, there is a final thing is isoleucine. All of them is aliphatic side chains. They are chemically inert and inactive. Usually they show their hydrophobicity. Okay. Okay, so for example, in chapter 5, we learned about in chapter 5, we learned that the parameter to show the ranking hydrophobicity. Alanine, they have 1.8, and the leucine 3.8, and the isoleucine, the 4.5, and valine is 4.2. It means that they are very hydrophobic. Okay. Another thing is that, for example, arginine and lysine, asparagine, aspartate, glutamine, glutamate, the minus value is higher. So in these cases, we call it as they are hydrophilic. But sometimes between them, for example, more serine, sometimes tyrosine, threonine, and this kind of thing, just we call it as just a hydrophobic. Okay, there is no direct, there is no strict there is no strict difference between the hydrophobic and hydrophilic. Okay, so usually for example, this is aliphatic, and the other one is they have minus charge is higher. They looks like the hydrophilic. Okay. Also, okay, so let's go to another thing. Important thing is the carboxyl group. So if they have the carboxyl group, first one is aspartate. Their simplest code is D. So we always in company we always say that the D. So if we call it as D, I always think about they have the carboxyl group. As maybe they have minus charge. I always think about it. Okay, so and you guys already memorized all of the structure and all of the simplest code. So whenever I call it as aspartate, so you will automatically think about D, and also you will automatically think about the structure. And also the very important concept is that in our question, so based on the question, so in our midterm exam, so nearly similar problem is question was presented like this. But important thing, you have to memorize all of their simplest code. And also there is a nearly similar question was like this. Okay. So we have to find the net charges. So important thing is first, we assume that pH is around 7. This kind of experiment is very sensitive to the pH environment. So we just assume that pH is around 7. Okay, so under these conditions, lysine and arginine is positive charges +1, and glutamate and aspartate is negative charges -1. And histidine, they have no charges. Okay. So, okay, based on this question, we just write down is like this. Okay, very important. So this one and this one is very important. Okay. Okay. And also asparagine, we call it as N. They have the amide group. This is, we call it C, carbonyl, this is CO and NH2, we call it as amide group. So they have the amide group, aspartate, asparagine simplest code is N. This is nearly similar to aspartate. Okay. And also another thing is the glutamine, Q. They also have amide group. They look like the glutamate. Okay. Okay, and we system methionine. Okay, lysine. So whenever I call it as lysine, maybe you automatically think about K, and also you will automatically can draw the structure is like this. So they will have plus charges like this. So in the company, we always say that we want to make the plus charges in the pocket of the protein. So at that time, because we already learned the protein engineering, and maybe you can think about maybe we can add lysine, okay, or we can add arginine like this, okay. Okay, and proline is the they have the ring structure is like this, okay. So this is a cis structure, and this is trans structure. In most of cases, 1-to-4 ratio, they are trans. Their structure is a trans configuration. For example, in our chapter 3 homework, so we just write down the secondary structure. So if there is a proline at the center, their structure will go to like this, okay? So they will make turn is like this, okay? Okay. So in the question, in the answer, you had better use the trans configuration, because the trans configuration is frequently available compared to the cis, okay? There's the histidine. Another thing is that we have the amino acid which has aromatic residue. Okay, phenylalanine, F, tyrosine, Y, and tryptophan. The important thing is that they can absorb only these 3 amino acids among 20 acids. Only these 3 amino acids can absorb UV region of electromagnetic spectrum. Only these 3 amino acids. So they have the epsilon number. So this is a molar absorptive coefficient. So indicates how much light is absorbed at a given wavelength. Okay, so this is phenylalanine, they have a ring, and this is the tyrosine, they have OH group, and the biggest one is tryptophan. That's why their absorbance epsilon value is highest. It's like this. Okay, so this is the Beer-Lambert rule. Okay, A observance is that epsilon multiply concentration in moles, and L means that light path length, centimeter. So based on this equation, so we can calculate it, the observance. And also our actual in our homework, this question was very difficult to understand. So what was concentration of the milligram per ml? It was very, very difficult to understand, but basic concept is this one. Observance is the epsilon multiply concentration and length. Is like this, because they have the 3 phenylalanine, they have 3 tryptophan, and they have the 6 tyrosine, and they have 1 phenylalanine. So equation is like this. Okay, this is very important. Okay, in actual exam, is you have to understand this concept to solve the midterm exam. Okay, very important. Okay, and also finally important thing is that stereoisomerism. Okay, so there is a DL stereoisomerism. Okay, and also there is the another RS stereoisomerism. So nowadays, most of people used RS stereoisomerism. Okay, so in actual exam, I will show you this one. So you don't have to memorize this one. The first one is we have to find chiral center containing 4 different groups. Just consider from the C alpha. Okay, so we have to identify chiral center, consider from C alpha, after C beta, C gamma, C delta, something like that. Okay. Now also prioritize 4 groups from the 1 to 4. 1 is highest and 4 is lowest. Okay, so this is the principle. It's like this. So today I will not explain the details, but in the actual exam I will show you this information. So based on this information, for example, the second one is we have the CH bond. Usually, first we have to CH bond have to be pointing away from the viewer at that length 3 remaining groups. So according to the priorities. So in this case, it's 1, 2, 3. So in this case, this is clockwise. So we call it as R isomer. So in this case, 1, 2, 3. The counterclockwise, we call it as S isomer. For example, threonine, they have 2 chiral center. Okay. In case of C, so they have the S configuration. And in case of the DC, they have the R configuration. Okay, so we call it as 2S configuration, and we call it as 3R configuration is like this. The threonine, they have 2S and 3R configuration is like this. Okay, the answer will be the 2S and 3R configuration. Okay, do you have any question? And also this one was citrulline, and then this is their structure. So we only can find one chiral center is like this, and just to write down the pointing out CH. After we can prioritize the location 1, 2, 3, something like that. So this is 2S is like this. Okay. Do you have any question about chapter 1? Do you have any question in chapter 1? Chapter 2? Okay. Maybe everybody already, everybody already understand all of them. Okay. 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 So let me go to the chapter 3. So do you have any question in chapter 3 homework or the actual class? Do you have any question? Chapter 3, do you have any question? Okay, so let me start from the chapter 3. And chapter 3 is 3-dimensional structure of proteins. Okay, for example, we cover first one was the primary structure or sequence. Okay, so the primary structure means the linear order of the amino acid residue from N to C. Okay, N to C is like this. And there is also the conservative transition, and also there is the non-conservative transition between the human myoglobin and the whale myoglobin. Okay. Okay, one example is like this. For example, I and V is that identified as just the yellow color. So when the conservative transition happens, we just designate yellow colors. For example, isoleucine and valine, they have aliphatic side chains. So in this case, so when they have aligned with I and V, so we call it as this is conservative transition. Also another case is like this. So for example, another case, if we designate the red color, so this is a non-conservative transition, okay? Okay, and also important thing is primary structure, okay? From to N to C, is it okay? From to N to C is like this, N to C is like this, okay? And also this is, if there is the proline is located at the center, so we can write down structure is like this, okay? Very important, okay? This is protein engineering course, and this concept is very important, okay? Okay, so in actually our chapter 3 homework, okay, so we just write down the, this is the, if there is no proline, so we can write down from the N to C. And this is the peptide bond, okay? And this is the C alpha, and between the based on C alpha, there's a pi and psi. Pi and psi is like this, okay? So we have to know this concept, okay, to solve the midterm exam, okay? Okay, so based on the C alpha, okay, based on C alpha, C and this one we call it as the pi, and between the C alpha and C, so we call it as this is the psi, is like this, okay? This is a dihedral angle, and dihedral angle is like this, okay? Okay, and also important concept is that this one, the alpha helix, okay? For example, alpha helix, okay, per turn, okay, this one pitch and the other pitch and third pitch, okay, one turn is composed of 3.6 residue, amino acid residue per turn, okay, and also per turn they will progress 0.45 nanometer. It means that the translational distance, the progression distance, the progression distance per residue or translation distance is the 0.45 divided by 3.6 is 0.15 nanometer. Okay, like this. Okay. Okay, and also another concept is that beta strand. There is two kinds of beta strand. One is antiparallel, the other is parallel beta strand. In most of cases, in the beta strand structure, in most of cases, the antiparallel beta strand, they have the N2C, N2C, N2C is like this. Parallel is N2C, C2N, N2C is like this. This is we call it parallel, this is we call it antiparallel. But in most of cases, the antiparallel strange. Okay, they have one pitch and the other pitch is like this. Okay, one turn, from one pitch to the another pitch, they have the two residue per turn. Okay, so antiparallel is their length is 0.68 nanometer per turn. Parallel is that 0.64 nanometer per turn. So actually in peptide bond, actual distance between the one amino acid, the other amino acid is 0.38 nanometer. So it means that antiparallel is the nearly stretched, okay, nearly fully stretched. But when fully stretched, their length is 0.38. Antiparallel is also nearly fully stretched, okay. So based on this concept, so we can solve we already solved the homework, this one. Okay, for example, fully extended polypeptide of 150 residue, so we can calculate. Or alpha helix, which is composed of 115 residue, or so we can calculate it like this. And also the beta strand, in beta strand there is two kinds, antiparallel and parallel. So you can calculate it like this. Okay. Okay, and another question was like this, myoglobin. Actually, the myoglobin structure we can see in the chapter 3. We can see the myoglobin. Okay, so actually the myoglobin is composed of the 8 alpha helix. 8 alpha helix turn, 8 alpha helix turn, alpha helix turn, alpha helix turn, like this. Their structure is like this. But based on this question, or how many the helical structure will be there. So based on question, first one we have to find the proline location. Okay. So in these cases, we only can find the 6. We only can find here 1, 2, 3, 4, 5. It means that there will be at least 6 helix structure. But actually, the myoglobin, they have the 8 alpha helixes. Okay. Okay. This is another example of our homework. Okay. Okay. And also we learn. Okay. So, for example, in the beta strand, at this case, in this turn location, maybe proline will be there. Okay. Okay, and also alpha turn, beta turn is there. And also another thing is that tertiary structure. Tertiary structure is stabilized by several bonding. Okay, first one is disulfide bonding, covalent bonding, and second one is hydrophobic effect. So hydrophobic effect is that this is important. In the presence of water, hydrophobic amino acid, for example, this kind of amino acid, in the presence, this is water. So in the presence of water, hydrophobic amino acid is clumped together. So and that interaction between hydrophobic amino acid happens. So this is, we call it as hydrophobic effect. Okay. Okay, this is one example. Hydrophobic effect we can calculate based on delta G. Delta G is delta H minus T. T is the absolute temperature. T is the absolute temperature. And delta G is the entropy changes. If their value is plus, they are hydrophobic. Not minus, they are hydrophilic. For example, most famous example is solid. When we put the solid into water, at that times usually the hydrophobic effect is happen. Hydrophobic effect is happen. So based on in here, we can say we find that delta H is 2 plus 2. T delta S is minus 3. it means that delta G is plus pi. It means that their hydrophobic effect plus is hydrophobic. So their hydrophobic effect, when we calculated the energy, is the 5 kilocalorie per mole. How about here? From liquid to the aqueous solution, delta H is 0 and T delta S is -6. Total G will be 0 minus will be +6 is like this. So their hydrophobic effect will be 6 kilocalorie per mole. Do you understand it? Very important, okay? Very important, okay? Also, there is another charge-charge interaction, and also hydrogen bonding, and also there is a van der Waals interaction. Finally, okay, so there is an interaction stabilizing tertiary structure from the covalent bond, ionic bond, hydrogen bonding, and hydrophobic. Finally, there is van der Waals interaction. Okay, so usually the covalent bonding is highest, around 200, and the weakest one is that this one, van der Waals interaction. This one is okay. So I did not explain some details in the van der Waals interaction. Okay, so there is a R divided by R multiply 6. Also divided by R R12 like this. So their value is very small. Okay. Okay, so the strongest one is covalent bond and the weakest one is van der Waals interaction. Okay. Okay, and secondary structure is okay, they have the secondary structure, they have the domain and tertiary structure. Tertiary structure is composed of the domain like this, okay? And also there is the quaternary structure. Quaternary structure is composed of the identical subunit or non-identical subunit. For example, HIV protease. Okay, so HIV protease is the very important role in the HIV infection, but I did not cover some details. So, but they have identical subunit is like this. For example, another case is hemoglobin. So they have a non-identical. Alpha and beta is not exactly the same. They are non-identical. They are composed of non-identical structure subunit. Okay. Okay, and we already cover in our the chapter homework. We cover the mechanism of oxygenation in myoglobin. So when this is the hem plate, when the O2 is located, is go to the iron. So O2 can induce the movement of the iron to hem plane to 0.2 angstrom is like this. So this is the mechanism of oxygen in the myoglobin. Okay, so we already cover some detailed information. So number 8 question. So we cover the covalent bonding, something like that. Here the important thing, most strongest one is covalent, most weakest one is van der Waals interaction. Okay, now so we learned about the mechanism of the oxygenation in myoglobin, and also we learned about mechanism of oxygenation in hemoglobin. So for example, in the hemoglobin, they have T state and R state. So when they have in T state, they are resistant to oxygenation. That's why they show that they are the their cover is fractionation of the fractionational saturation. They look like this form, like this. But R state of hemoglobin, they bind oxygen very readily, so they will make the hyperbolic curve. But usually the observed binding profile of hemoglobin is reflect some of the R and T stage. So this is T state and R state. Okay, so in T state, there is the one interaction is like this. Okay, in the R state is another interaction is like this. Okay. Okay, so actually this is also another example. The question was like this. What are the advantages of more than one subunit within proteins? So how are multimeric proteins are stabilized? Okay, this is one example. Okay, you can find this answer in hemoglobin. Okay, very important. Okay, you have to understand this concept. Okay, in the midterm exam, I will show you this figure. So you have to explain this phenomenon. Okay. 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 Very important. For example, each subunit, there the oxygenation. Okay. So each subunit of hemoglobin has a lower binding activity because their K1 value is very small. The oxygen, so they have a lower binding activity. But when they become the multimeric structure, so this is they show the sequential mode. Okay, so actually the K1 is the exactly same as this K1. But after one subunit bind to the oxygen, the surrounding subunit are more readily to bind to the oxygen because K2 is increased compared to K1, and K3 is also increased compared to K1, and finally K4 is also already increased compared to K1. So it means that based on this sequential model, so when they make the multimeric proteins, so after one subunit bind to the oxygen and surrounding subunit is more easily bound to the oxygen. That's why multimeric protein have more advantage than the one subunit. So in this case, for example, in hemoglobin cases, their stabilization occur between the beta subunit and alpha subunit is like this. Okay, so this is the answer. Okay, so this is very important. Okay, this is quaternary structure of protein is very important. Okay. So we also cover final concept in the chapter 3 is the immunoglobulin. So immunoglobulin is composed of heavy chain and light chain. It's like this. Notice heavy chain is composed of the constant region, notice variable, and the light chain is also composed of the constant region and variable region. And we call it as this region as the complementary determining region, CDR region. So this is actually the antigen binding site. Okay. So nowadays, whenever we make the therapeutic antibody, we can make the full amino acid structures like this, or sometimes we can make we can take it out this structure. We can only take it out the CDR region, Okay, so we also sometimes use this antibody for the therapeutic antibody. Okay, this is the Cynthia. Okay. And also we learn about several the antibody type A, D, G, M. And most of the therapeutic antibody is IgG. Okay. So they have the gamma, heavy chain is gamma, and white chain is the kappa, while the lambda is like this. Okay. Okay, so also okay, this is the nowadays the this is the for autoimmune disease. Nowadays, all of the autoimmune disease patient is received this kind they always get this antibody. Okay, for example, this is the Remicade and Cynthia and Humira and Enbrel. They are always targeting TNF alpha. Okay, because all of the autoimmune disease patient, they express TNF alpha. So after we injected this antibody, so after we inject this antibody, all of autoimmune disease is depressed. Okay, so we can survive. Okay. Okay. So for example, Celltrion, they made Remicade biosimilar, and Samsung Bioepis, they made the Humira biosimilar, and also Enbrel biosimilar. Nowadays, the Celltrion and Samsung Bioepis become #1 and #2 in biosimilar company in the world. Okay. Okay, so nowadays people use this antibody for therapeutics. Okay. Okay, and also cover this one. Okay, and this one. Okay. Okay. Any other question in chapter 3? People, did you understand all of them?
Yeah.
Okay, so we have to memorize it. Okay, for example, amino acid structure, we have to memorize. There is no way just to memorize. Okay, okay, there is no way. Okay, any other question? Okay, so maybe this Friday, this Thursday, so we will cover chapter 4 and chapter 5. Okay. Okay, so if you have any question, please let me know. Okay. Okay, so today we will finish class. Okay, bye.
고맙습니다.
Okay.
고맙습니다.
감사합니다.